You know, it's a good thing that a lot of people are concerned with the environment these days, and they're willing to educate themselves. So I'm just going to briefly take a little bit of my time to describe what I feel are some important things that need to be understood for us to... what I'm going to discuss here today is some of the causal problems that result in global warming. Now, there's a lot of discussion of global warming, but we should stick to the science. There are several factors which contribute to the increases in global temperature, but one of them is loss of sea ice. Now, the sea ice is melting more rapidly, which exposes more water and more land when the snow melts, and so the combination of loss of sea ice, loss of glaciation, and loss of snow mass on the land increases the amount of heat absorbed. Arctic ice shrinkage is defined as the decrease in the size of the Arctic ice pack in the northern region. Because of the rapid response of the Arctic to global warming, it is often seen as a highly sensitive indicator of climate change. Scientists also point to the potential of the release of methane from the Arctic region, especially through the thawing of permafrost, which contains a lot of organic matter and could therefore release a tremendous amount of methane into. Basically speaking, what happens when the Arctic ice volume area is reduced, the amount of sunlight reflected back into space is also reduced, which heats the atmosphere. So the rate of decline of the ice pack is accelerating. From 1979 to 96, the average per decade decline was 2.2%. Since that time, there's been an additional 3% decline. For the decade ending 2008, these values have risen to 10% and 10%. The important thing to remember is that a 2010 study attributes the recent temperature increases and the amplification, the sudden increase in overall temperature, was caused by the shrinkage of the ice itself, which exposes to sun, water, and soil instead of being covered with ice. And the water and soil have a much lower reflectivity than the ice does. So the effect of Arctic ice shrinkage is a marked increase in Arctic sea ice melting and melting of the permafrost. The permafrost is a sink for methane because it has a lot of organic material. So when the permafrost melts, there's an increased release of methane. And the sea ice in the Arctic is itself important in maintaining global climate due to its albedo reflectivity. Melting of this sea ice will therefore exacerbate global warming due to positive feedback, which is heat absorption. This runaway climate change could potentially be caused by the release of methane gas, which, as I said, is 10 times or more of a heat-absorbing gas than CO2. Now, sea ice loss has melting effects on permafrost. So in other words, when the sea ice melts, the permafrost starts to melt. In the past, temperature changes and salinity changes in the ocean have caused interruption of our ocean currents, like the Gulf Stream and the Japanese current. So what this means is there could be a shutdown of thermohaline circulation, which is the ocean currents. In addition to the loss of reflectivity due to the loss of the albedo effect, there is also a considerable amount of difficulty caused by black carbon. Black carbon warms the Earth by absorbing heat in the atmosphere and by reducing the albedo, which is the ability to reflect sunlight when it's deposited on snow and ice. Effects for black carbon is the third largest contributor to global warming. And there's a positive note here. Atmospheric particulate carbons have a very short lifespan, maybe a couple of weeks before they're deposited on the ground or on the ice or on the glaciers. So therefore, reducing atmospheric carbon particulates would very rapidly have a positive result. So in conclusion, I would just like to say that my research indicates that atmospheric carbon, in particular particulate carbon that comes from coal fire, oil fire, the incomplete combustion of hydrocarbons, combined with CO2 and methane release, reduces the albedo effect, which the albedo effect is the reflectivity, the reflection of heat back into outer space from ice and snow. So when we lose our ice and snow, we're not just losing someplace to go skiing. We're heating the planet. The heating of the planet heats the permafrost and it heats the ocean, which melts more ice. When the permafrost heats, it releases methane. And as I said, methane is 10 times worse a greenhouse gas than CO2. So we need to have a meaningful discussion about how to reduce atmospheric carbon particulates, to reduce the increase of melting of Arctic and Antarctic ice. We need to reduce the release of methane into the atmosphere and CO2. These are reasonable goals that could be achieved by thoughtful people. So let's give it a try.